Hello friends, welcome for another deep learning project. Here we will do review classification using BERT, that is bidirectional encoder representation from transformers. And before building the model, we will discuss what the steps we will do to do this project. So at first I am using a dataset available in Kaggle, that is Spotify dataset. So let's move to the dataset. I will show you what the contents available in that dataset. So this is the dataset, Spotify user reviews. It is available in Kaggle platform and it contains around 51,000 plus user reviews. So you can see here 51,473 rows are available in the data frame, and we have two columns. One is review, another is label. Review is this column contains the user review reflecting their experiences, opinions and feedback on the Spotify app, and the label column categorizes each review as either positive or negative. And here you can see 56% of the total reviews are negative and 44% of total reviews are positive. So this is what the dataset I have used to build this model. So let's move to the model place. So this model is built using BERT. So I have explained about BERT in my previous videos. I will explain it again here in the notebook. So let's move to the notebook section. So BERT, it is a deep learning model based on the transformer architecture, specifically using only the encoder part of the transformer. So we will discuss on BERT. It is a deep learning model based on the transformer encoder. It's nothing but transformer encoder. I hope you know about transformer encoder. If you don't know about it, please watch my previous videos on transformers. So let's break down the architecture. The backbone model of BERT will have an encoder layer stacked either 12 or 24 times as per requirement, then an objective layer. It's very simple. It will have an encoder, transformer encoder especially. So a transformer encoder, then an objective layer. As we know, the transformers do not remember the word orders, therefore we need to implement position embeddings of the tokens that we feed to the model. So the input what we feed to the model will be processed with token embedding and position embedding. So this is the whole architecture of BERT model. So the objective layer will contain only the dense layer and dropout layer for the objective part, and we will feed input in the form of 3 dictionaries. I am talking about input representation, which should be followed when we use a BERT model. So the input representation should have token IDs, that is the token meanings in numerical form, which we will feed to the model. Then padding mask indicates each token whether that is present in the text or not. So it indicates whether a token is currently present in the text or not. In this sequence, let's change it to in the sequence or not. So you will understand it better with an example. Let's say we have India is a beautiful country. Let this be our sentence, and its tokens will be like this. Let's think. For India it is 1, for each it is 2, for A it is 3, for beautiful it is 4, for country it is 5, for dot it is 6. And if we want to have the sequence length of fixed size, then we need to add masking tokens, that is zeros, and because of that we need this padding mask for masking the tokens which are not available in the current sequence, but to make the sequence of fixed size. So if we want a sequence of 16 tokens, let's say, then we will have like this: 9, 10, 11, 12, 13, 14, 15 and 16. This will make our input of fixed length. So this is what the padding mask does, and don't worry, I will show it with the tokenizers available in Keras Hub. And the next thing is segment IDs. It indicates whether a sequence of tokens or text or phrase belongs to one passage or sentence. If we take the same example that India is a beautiful country, then our sequence ID will look like this: 1 1 1 1 4 16 times. For first sentence it will represent 0, for second sentence it will represent 1, and for third sentence it will represent 2, like that. Also this should be in D type of int 32 or int 64 or float 32. So let's build our model. So to build our model, we have imported the required libraries like Keras, Tensorflow, Keras Hub, Pandas, NumPy and scikit-learn. Keras, TensorFlow and Keras Hub are used to build the model, while Pandas is for working with the data frame, that is data manipulation. NumPy is for numerical calculations, while scikit-learn is used to split the dataset into train, test and validation parts. Let's import all these. After that, using the mirrored strategy method, we are creating a strategy which can be used during training the model so that training can be accelerated with the GPU. So let's see how many number of cores available in the distributed system with the attribute number of replicas in sync. So here you can see we got 2, that means 2 devices are available in the system, and using the read CSV method we are loading the dataset.csv available in this location, and you can find that in the input section. This is the dataset I have added through this add input button and copied this file path and pasted over here, and using that file path reading with read CSV method into a data frame, and let's get the first 5 rows. So you can see we got 2 columns, one is review, another is level, and in review we have reviews of users, and in level we have 2 classes, positive and negative. So let's see if any duplicates are available in the data frame or not. For that we have a beautiful method duplicated, along with when we apply sum it will return the total number of duplicates rows available, and as we got 1229 duplicate rows, we will remove these. So to remove we have dropped duplicates. If we pass in place equal to true, it will change to original data frame and save inside the original data frame. And if we want to ignore the index, that means index will be reordered. So let's drop all the duplicates. All the duplicates are dropped. Let's see if any null values are present using the method isNull with sum, so that number of null values will be returned. So in review we have 1 null value. So to drop null values we have drop NA method, and again in place equal to true and ignore index equal to true to change the original data frame and to maintain the order of indices. And let's see the data frame information. So here you can see now in total we have 51,471 rows, and 2 columns we have review and level, and we do not have any null values. So you can see 51,472 non-null values, and both are of object types. So let's see the percentage of value counts of positive and negative. So you can see, to be precision, 57.011579 is total percentage of negative and remaining of positive. After doing all this, we have to generate the data set to feed our model. So to generate data set, we have a method from tensor slices available in TensorFlow. Before doing the generation of data set, we need to do some things like convert the text into integer. So for that we will build a lookup layer which will carry out the lookups of vocabulary or values negative and positive. So for that we are using a string lookup layer and we are providing vocabularies negative and positive. So remember, when we provide negative at index 0, so when it returns 0 it means negative, and when we have positive at index 1 and it returns 1 for positive, and number of out of vocabulary indices is 0, that means out of negative and positive we won't allow any other vocabularies. And output mode is int, that means we are not using one hot encoding, and that's why it will return 0 for negative and 1 for positive. Let's build this lookup layer. As we already have the vocabulary, so we don't need to adapt the lookup layer, and if we don't have the vocabulary then we need to adapt the lookup layer. After that we are splitting the dataset into train, test and validation. First of all we will split the dataset into train and test, then using the test data we will split into validation and test. That's what I have carried out here. Using the train test split, we are providing x value, that is review column, and y value, that is level column. Then having test size equal to 0.2, that means 20% of the data is reserved for test size, and then random state equal to 42 to regenerate the same values, and having the stratify with y levels because we have the unbalanced data set. You have seen that 57% of reviews are negative and 42% of reviews are positive. That's why we will stratify so that we won't get any imbalanced data. After that I'm printing xtrain sep and ytrain sep. So sep of both xtrain and ytrain, which should be equal. Let's see. So you can see we have 41,177 rows in xtrain and ytrain. After that, using the xtest and ytest, we are splitting 50% to validation and 50% to testing, and again having the random state equal to 42 and stratify equal to ytest, and printing the sep of validation values. Let's run this. So 5,147 rows are reserved for validation and remaining for testing. So after train, test, split and lookup layer, we will generate the TensorFlow dataset using the function dsGenerator, where we will provide the x, y and string arguments. The x is nothing but the column, that is reviews, and y is nothing but the column levels, and string indicates whether it is for training or validation or testing. So when we provide x, y, we will do lookup of y, and with x we will create a tuple and generate a data set using the from tensor slices method. And if string is true, then we will shuffle with buffer size 1000 using the shuffle method, and after all we will return the dataset with batches of 128 element per batch. So this is the function dsGenerator. Now let's use that function for creating train dataset, validation dataset and test dataset. Let's run this. So let's see whether datasets are created correctly or not. So for that, taking one base from train dataset and printing the first element from the page. So you can see it has returned great music up, lots of choice, only listen occasionally, so I don't use premium but still enjoy the control over the music and the choice. Having to listen to some commercials is absolutely fine. And here it indicates 1, that means it is a positive review. Okay, so all are correct. After this, we will pre-process our data. We will be pre-processing. First of all, we will tokenize using the tokenizer and also pre-processor. We will go for generating token IDs, padding mask and segment IDs. So first of all, let's load a preset BERT tokenizer. The BERT tokenizer follows word piece tokenizer, and this BERT tokenizer is used to tokenize our sentence into tokens, and this will convert the sentence into tokens and into vectors of integers. So it is available in Keras Hub library, and we are loading a preset that is already trained tokenizer using the preset BERT base en. BERT is for BERT model, base means 12 encoders, en for English. So we will get this tokenizer. Let's run this. So we are loading our tokenizer. Tokenizer is loaded. So let's see some tokenization and de-tokenization, so that it will clear you how it is tokenizing and how it is de-tokenizing. For that, we have a tokenize method where we need to provide a text, and I have provided it's a good app if you want to listen to music and have 4 ads after every 2 seconds. So let's get the tokenized value of this. So here you can see this app is 21 and d type is int 32 and values is an array of these values. Now let's de-tokenize and convert back this array to the text format with the de-tokenize method, and inside we need to provide the tokenized values or the arrays. So let's run this. So here you can see it's a good app if you want to listen to music and have 4 ads after every 2 songs. You can see this tokenizer have generated the same what we have given. And similarly, we have a BERT text classifier preprocessor, which we will load from the Keras hub, and inside that preprocessor we are using the same tokenizer we have used for this example, and we are converting each sequence to of length 128. Let's load this preprocessor. Preprocessor is loaded. Let's see how the preprocessor works. So again I am providing the same text, and let's do the pre-processing. The pre-processing will return 3 things: input IDs, padding mask and segment IDs. And input IDs are also called token IDs. Please don't get confused. So let's get this. So here you can see token IDs of SEP 128 because we given sequence length equal to 128. So here you can see these are values of the tokens. Token IDs represents tokens. Here we have just discussed token IDs, the tokens or token meanings in numerical form which we feed to the model. Okay, and you might be thinking that it is starting from 1135 and ending at 2040, but here you can see starting at 101 and ending at 102y. So the preprocessor will add a special resolve token, that is CLS. It indicates the beginning of a sentence or sequence, while 102 indicates the separation of sequence. So up to here this sequence is available, and after that we will have other sequences, and here zeros are added to mask, and these will be masked in the model. Now we have padding mask of SEP 128 and D type boolean. So true, 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 and false remaining all. It indicates that whether these are available in the text or not. As these mask values zeros are not present in this text, that's why returned false, while these numbers 101 to 102, these values are available, that's why all are true up to there. I hope you are understanding what I am speaking. For these non-zero values, it is showing true, and for all the zeros, it is showing false. This indicates that whether the word or token is present in the current sentence or not. Okay, after that we have segment IDs, and it is all zeros because all zeros indicates that the whole sentence is of one sequence, and there is no second sequence or third sequence. I hope you are understanding. It's a good app if you want to listen to music and have 4 ads after every 2 songs. This whole is one sequence for the model. That's why it is considering this is one sequence and the sequence number is 0. If it gets second sequence, that means it will return 1 for the second sequence, and for third sequence it will return 2. Likewise it will carry out. And one thing I want to tell you that notice the D type of token IDs, padding mask and segment IDs. And when I discussed about this, I told that all the values should be in integer type or floating point type. But here in this case the preprocessor returning boolean type for padding mask, so we need to change that to integer type. For that we are converting the boolean type to integer type with a cast method, and we will do that later. So move on. So we are just pre-processing the train dataset, validation dataset and test dataset, and generating the token IDs, padding mask and also segment IDs. As padding mask is of D type boolean, that's why we need to cast to integer, So with a function bool to int 32, we will cast the padding mask type to int 32. So in this function we are passing two things, one is x, another is y. The x is nothing but this dictionary from token IDs padding mask to segments, the whole dictionary, and the y means levels. So if x of padding mask is of d type boolean, then we will convert that to integer with this cast method, and we will return x and y. Let's create this function, and after creating that function we will map that function to the data sets, and we will convert the padding mask to integer type. So let's convert these: train dataset, validation dataset, and test dataset. So here I have provided two more things, that is number of parallel calls equal to tf.data.autotune and prefetch equal to tf.data.autotune. And for knowing the purpose of these things, please watch my previous videos. And this is the task for the watchers of this video. After this we will build our model. So as the Keras Hub provides BERT text classifier, we will load a preset version using the preset BERT base en. So we will load that BERT text classifier, and here as we have only two classes, that is positive and negative, that's why we are providing the argument number of classes equal to 2, and we will use sigmoid activation at the last or top layer. And as data is already pre-processed, that's why we are providing preprocessor equals to none. And now we won't train the backbone, and we only train our top layer, that is the classification layer, so that the classification layer will train itself and classify out all the reviews into positive and negative. For that case, classify.backbone.trainable is set to false, and we will compile the classifier with optimizer Adam with the learning rate 5e minus 5, that's nearly equals to 0.0005, and we will be using sparse categorical cross entropy because the levels are of integer type, and we are using accuracy as matrix. Let's compile our model. Wait a while. Model is compiled, and let's train our model with the train dataset and validation dataset for validation, and we have 3 epochs. After all 3 epochs, we got 67% of accuracy and 70% of validation accuracy, loss of 0.6143, and validation loss of 0.5910. Okay, it's okay, but what if we will fine tune it? So we will fine tune it later. After doing this model evaluation, we will evaluate our classifier model with the test data. Let's see what are the results. So we got accuracy of around 72% or 73% and loss of 0.58, I think we may get better accuracy and better loss if we do fine tuning. That's why we have done fine tuning. So for fine tuning, I am resetting the backbone to trainable, then with a very minute learning rate nearly equals to 0.00001. I am recompiling the model. So let's recompile and let's retrain the model for 2 epochs. After the second epoch, the accuracy has reached to 80% and loss is to 0.49. What a great change after fine tuning. And the validation accuracy is reached to 0.8341 and validation loss to 0.4199. Wow. So let's re-evaluate the classifier after fine tuning with test dataset. So you can see there is a great change. We got accuracy of 85%. Wow. And loss of 0.41. Superb. So let's build an inference model with raw text. So for that we will create a function called inference model. Now for this function we will provide a raw text, and this raw text will be pre-processed. So remember that you should make a list of raw text to pre-process, or else you will get an error. After pre-processing, just convert the padding mask to integer type, then pass that pre-processed text to predict, then it will return two values. Find out the index of the maximum value from the two value and set that in level. If the level is equals to 1, that means it is a positive review, and else it is a negative review. So let's test our model with the review. The review is that Spotify is a worst app, never use it. I don't want to listen this recommendation from Spotify. This is a review given by me. Let's see what it should return. I hope it should return negative review. Oh God, please return negative review. God may not return negative review, but our model is returning negative review. Let's change it to other review, a positive one for now. Let's say this Spotify app is too good, working well, good interface for songs, and it provides high quality songs. So let's run this. It's a positive review and it should return a positive review. Yeah, see guys, it is returning a positive review. Wow, our model is working too good. So thank you very much. Have a great future. You can use this model for building the classification models, and it's very easy. Follow all the steps that I have described and explained. So thank you very much.